Hello everyone. Today we are going to be going through how to graph simple polynomial graphs. Let's start with our cubic graphs. Now in the last video, we determined that the normal structure of a y equals x to the power of 3 graph has a point of inflection at 0, 0. And it looks something like this. The point of inflection being here. Now, what a point of inflection means is that on one side of the graph, we are curving downwards, and on the other side of the graph, or the other side of the point of inflection, the graph is curving upwards. Now, we can actually change the position of our point of inflection. This is most obvious when our equation is written in the form y equals a brackets x minus h to the power of 3 plus k. What h suggests is a translation in the x-axis. So this moves our point of inflection either left or right. The k over here moves our graph either up or down. So it moves our point of inflection either up or down. So for example, if we have a graph of y equals x minus 2 to the power of 3 plus 1, our point of inflection will be at 2, 1. If we were to graph this over here, taking note of the coordinates of our point of inflection at 2, 1, so that's over here, we will get an upward sloping graph with its point of inflection at 2, 1. Now, say we had a negative out the front over here. So instead of having y equals x minus 2 to the power of 3 plus 1, we've got y equals minus x minus 2 to the power of 3 plus 1. What this would do is just make our graph slope downwards instead of upwards. So your point of inflection will still be at 2, 1, but the shape of your graph would change. So let's have a look over here. There we go. So here's your point of inflection at 2, 1. But because we have a negative out the front over here, this would make our graph slope downwards rather than upwards, even though it has the same point of inflection as the last graph. Now, you will also find some cubic graphs written in their factorized forms. For example, you could have y equals x minus 2 times x plus 3 times x plus 4. The x-intercepts of this graph can be determined by using the null factor law. So generally, to find our x-intercepts, we would make y equals 0. So 0 equals x minus 2, x plus 3, x plus 4. However, what we will do is use the null factor law, which allows us to split each of these factors into their own equations, giving us 0 equals x minus 2, 0 equals x plus 3, and 0 equals x plus 4. We can use these three equations to figure out our x-intercepts. So rearranging for x, this would give us x equals 2, this would give us x equals negative 3, this would give us x equals negative 4. So our x-intercepts will be at negative 4, negative 3, and 2. Again, drawing this on a graph, we make note of these x-intercepts. So we've got x equals negative 3 here, x equals negative 4 here, and x equals 2 here. Again, because each of our x's do not have a negative out the front, our graph will begin by sloping up. It will begin by sloping up and cross the x-axis first at x equals negative 4, before curving back down and crossing through the x-axis at x equals negative 3, before coming back up to cross the x-axis at x equals 2. have a go at graphing this graph. Did you have a go? Let's go through it together. First step, find your x-intercepts. Hopefully you were able to use the null factor law to find these three equations that will help us find the x-intercepts. Solving for x in each of these should give us x equals -1, x equals 4, and x equals -5. As we get to graphing these, let's take note of the x-intercepts first. So x equals -1 over here, x equals -5 over here, and x equals 4 over here. Again, noting that we do not have a negative out the front of any of these x's or out the front of the entire equation, we know that our graph will begin by sloping upwards. Your graph will slope upwards until it reaches x equals -5, crossing through the x-axis at this point before curving and turning back around to pass through the x-axis at x equals -1. It will then come up again to pass through the x-axis at x equals 4. Now, sometimes you can have an equation written in the form y equals x minus 1, x plus 2 squared. So essentially, you can think of this as two of your x-intercepts are going to be x equals -2. So using the null factor law, you'd get x plus 2 equals 0, and your x-intercept would be -2. But because this is squared, another way to think of this is that you would have two x-intercepts at x equals 2. And your other x-intercept, you guessed it, would be at x equals 1. Again, using the null factor law, x minus 1 equals 0, so x would equal 1. So you've got two x-intercepts this time at x equals 1 and at x equals -2. So let's see what the implication of this would be. Again, drawing up our graph, we will be taking note of the positions of our x-intercepts. So x equals 1 being over here, and let's put x equals -2 over here. As we've seen before, there is no negative out the front of our x's, meaning that the graph will start by sloping upwards. Now, let's come back to the previous statement that I made about the squared over here, suggesting that essentially you've got two x-intercepts at x equals 2. What this means is that your upward sloping graph will not pass through the x-axis at x equals -2. Instead, it will bounce off the x-axis at this point, before curving down and curving up again to pass through x equals 1. Now you have a go. Try to graph y equals x plus 2 times x minus 6 to the power of 2. Now that you've had a go, let's go through this together. Our x-intercepts of these graphs would be x equals -2 and x equals 6. Noting the square over here, suggesting that two of our x-intercepts occur at x equals 6. So the square suggests that essentially two of our x-intercepts are occurring at x equals 6. What this means is that the graph will not cross the x-axis at this point, but will actually bounce off it. So this graph will bounce off the x-axis at x equals 6. All right, let's draw up our graph. Okay, taking note of our x-intercepts, so x equals -2 and x equals 6 over here. Again, there is no negative number out the front of our x's. This means that our graph will start by sloping upwards. Sloping upwards, the graph will pass through the x-axis at the point x equals -2. before going up and curving back down to x equals 6. Now remembering that there is a squared in the equation. There is a squared in this part of the equation. This means that at x equals 6, the graph will bounce off the x-axis rather than passing through it. So over here, we have a bounce off the x-axis rather than passing through it, creating your completed graph. Okay, let's try some of these with negatives out the front. So for example, say we have a graph of y equals x minus 2, x minus 3 squared with a negative out the front. Again, your x-intercepts would be at x equals 2 and x equals 3. Note the squared in this part of the equation. So this means that the graph will bounce off. It will bounce off the x-axis at x equals 3. So drawing our graphs, we will make note of our x-intercepts. So here is x equals 2 and here is x equals 3. Now note that we have a negative out the front of this equation. The only thing that this changes is that our graph will not begin by sloping upwards, rather it will begin by sloping downwards. So your graph will slope downwards to your x-intercept of x equals 2 before passing through the x-axis at this point, curving and coming back up to your x-intercept at 3. Remembering the squared in this part of the equation, this suggests that the graph will actually bounce off the x-axis at x equals 3. So over here, the graph will continue to bounce off the x-axis and proceed downwards. This one could have been drawn a lot better. Let's do that once more. So we slope downwards because of the negative out the front. The graph goes through the x-axis at x equals 2 before curving back up, bouncing off the x-axis at x equals 3, and continuing its path downwards. Let's try this with another graph. Let's try y equals negative x plus 4, x minus 3, x plus 2. Again, taking note of our x-intercepts. Our x-intercepts will be our x equals negative 4, x equals 3, and x equals negative 2. Taking note of these on our graph. Our x equals negative 4 would be over here, x equals negative 2 over here, and x equals 3 over here. Again, noting the negative out the front. What does this change? Yep, you guessed it. Our graph is going to begin by sloping downwards rather than upwards. So the graph will slope downwards, cross the x-axis at x equals minus 4, before curving back upwards to cross the graph at x equals negative 2, and coming back down to cross the x-axis at x equals 3. Now, hopefully this gave a bit of an overview on how to graph some simple factorized polynomial graphs, specifically cubic graphs. Please let me know if you have any questions. Otherwise, I will see you next time.